Hey team, it's Mr. Z. Last time we did part 1, we kind of warmed up. We reviewed lesson 2, we reviewed lesson 4, and then we've taken a step to solving some equations using the inverse of exponents, which is a radical. Now we're going to solve some equations with radicals. This is the entire focus of this section, is just solving equations with radicals. Square roots, cube roots, I'm going to show you how to do them all. Let's take a closer look. Okay, so it says solve the equation, check for extraneous solutions, which is a fancy word for a solution that might not work. All right, the square root of what number equals 16? So when you're solving this, when there's no index, it is assumed to be the square root, right? I'm assuming that this is going to be an index of 2. And I'm going to go ahead and raise both of these to the second power. So I'm going to take the square root of x. I'm going to take 16. I'm going to put a grouping symbol around both of them. And I'm going to square. This is going to result in just x, right? And then 16 squared. You're going to go ahead and multiply. You can go ahead and just do 16 times 10, which is 160. 16 times 6, which is 96. 160 plus 96 is going to be 256. What I did is I did 16 times 10 and then 6. So x is going to be 256. I need to check to make sure my solution is correct. So I'm going to take the square root of 256, which is equal to 16. And that does indeed equal 16. So I know that this is a true blue solution. However, with radicals, I do need to check. Number 2. Okay, so when you're doing inverse operations, remember parentheses, exponents, multiply and divide, add and subtract. Before you do anything with the exponents, you have to add and subtract and multiply and divide. So I'm going to get this radical by itself. I'm going to subtract 4 from both sides. This is going to result in an equivalent equation where I have the square root is equal to 5. Now I can go ahead and square both sides. So I'm going to take the square root of x, I'm going to take 5, and I'm going to draw a grouping symbol around both sides and raise them both to the index. This is going to result in x as being 25. Let's make sure this is right. If I plug in x, square root of 25 is 5 plus 4, which is equal to 9. Hell yeah. So these have been the 2 starter questions. Both of these are radicals. I've been able to solve them and find a solution. Let's go ahead and keep this going. So number 3. I have to figure out the square root of what number minus 1 is equal to 10. So since it's all by itself, the radical, I'm going to go ahead, it's to the second. So I'm going to go ahead and raise it to the second power to both sides. So I'm going to take the square root of x minus 1. I'm going to take 10, and I'm going to multiply them by themselves. This is going to result in x minus 1, which is equal to 10 squared, which is 100. Then I'm going to get my x by itself. I'm going to add 1 to both sides. This is going to result in x is equal to 101. Before I can confirm that this is a solution, I'm going to take the square root of 101 minus 1 should be 10. The square root of 100 is indeed 10, making 101 my solution. Number 4. Remember, before you do anything with the exponent, you got to get the radical by itself. So I see that there's a minus 2. I'm going to do the opposite in order to create a equivalent equation where 7 is equal to the square root of x plus 3. Now that the radical is by itself, right, the radical is square root of x plus 3, I'm going to square both sides, which is going to result in 7 times 7 is 49, which is going to be x plus 3. Now that the radical's gone, I'm going to go ahead and subtract 3 from both sides. And then this is going to produce x is going to be equal to 46. Let me make sure that this is right. 5 is equal to the square root of 46 plus 3 minus 2. 5 is equal to square root of 49 minus 2. 5 is going to be equal to 7 minus 2, which is absolutely true. So in all of these examples, what essentially I did was I solved them. I isolated the radical before I got rid of them. Remember, that's the essential key. And number 2, number 4, I had to isolate, aka get it by itself, and then proceed. Okay, let's keep going. So now I have 10x minus 1 minus 7. So I'm going to go ahead and I have to somehow get a negative 5. Well, I see that this minus 7 is on the outside, so I'm going to add 7 to both sides, right? I'm going to be left over with this, the radical square root of 10x minus 1, and then over here it's going to be equal to 2. Now that I have the radical by itself, I'm going to square both sides, and then this is going to eliminate that radical, making it an equation I know how to solve. 2 squared is 4. I go ahead and continue with my inverse operations, trying to get my x by itself. I get 10x equals 5, and then x is going to be equal to 5/10. I could reduce this. This is also equal to 1/2. When I do the check, I plug in the square root of 10. I'm going to multiply it by 5/10. I could even use 1/2 here. Minus 1 minus 7 equals negative 5. When I take these two and multiply them, the denominators cancel, leading to 5 minus 1 minus 7 equals negative 5. Square root of 4 minus 7 equals negative 5. 2 minus 7 doesn't equal negative 5. Absolutely. X is going to be 1/2. Okay, let's continue. Number 6. I have a coefficient in front of the radical. So I'm going to get rid of that so I can isolate it before I do anything. So I'm going to divide both sides by 2, the opposite of multiplication. And this is going to lead me to have the cube root of x plus 4, which is equal to 5. Now I can go ahead and raise each side to the third power. This is going to produce x plus 4 because the radical goes away. And then I have to figure out 5 times 5 times 5 is 125. I subtract 4, I subtract 4, and then I get the x value of 121. Now, let's see if that works. I do 2 times the cube root of 121 plus 4 equals 10. This turns into 2 times 125 equals 10. The cube root of 125 is 5. 2 times 5 is indeed 10. Therefore, my solution is correct. Number 7. My radical is by itself. I see it's to the 4th root. So what I'm going to do is I'm going to raise both sides to the 4th power. So I'm going to raise 3. And I'm going to raise 4, 5x minus 1. Notice how the inverse operation, I always apply the index to both sides. This is going to lead me to having just 5x minus 1 equals 3 to the 4th, which is 81. I continue to use inverse operations. I add 1 to both sides. This is going to result in 5x equals 82. I divide by 5. I divide by 5. X is going to be 82 divided by 5. When I check it, I plug it in for my fourth root. It is going to be 5x minus 1. What is the value of x? It is going to be 82 over 5 minus 1 equals 3. So when I multiply these two, my denominator disappears. I'm going to have the fourth root of 82 minus 1 should be 3. The fourth root of 81 is indeed 3. My answer is correct. Okay, number 8. I need to get my radical by itself. I need to isolate it. The way I'm going to isolate it is through my inverse operations. Remember, PEMDAS. Usually I go top to bottom, but for inverses, I go the opposite direction. So I'm going to subtract 5 first. This is going to lead me to have 3 times the fourth root of x minus 1 equals 15. Now I'm going to get rid of the 3 because I've added and subtracted. Now I'm going to divide. This is going to lead me to the fourth root of x minus 1 equals 5. Now I can take care of the radical. This was the setup. You get the radical by itself, and then now I'm going to raise it to the index. It is to the 4th power. So on the left, it's going to be x minus 1. On the right, it's going to end up being 625. I add 1 to both sides, and it's going to be 626. Now let's check to make sure that this is right. I'm going to do 3 times the fourth root of 626 minus 1 plus 5 is 20. 3 times the fourth root of 625 plus 5 equals 20. I'm going to continue to simplify. This is going to turn out to be 5. Now I have to multiply before I add. And yes, this is indeed a solution. So you might be asking yourself, well, all of these have checked, right? That means all of them should work. Nope. And number 9 is going to raise a question to that regard. All right. Number 9, the radicals by itself. So what I'm going to do is I'm going to raise both sides to the 2nd power. So it's going to become x plus 2 equals the square root of 3x plus 10. I'm going to raise both of them to the 2nd power. And on the right side, it just becomes 3x plus 10. On the left side, though, what I'm going to do is I'm going to write it out in expanded form. I'm going to multiply x plus 2 times x plus 2. Now, this is where you might want to use your area model if you need to. X plus 2 times x plus 2. This is going to produce x squared, 2x, 2x, and 4, meaning this is going to simplify to 4x plus 4 equals 3x plus 10. So notice what happened. This is the second type of radical problem. I got rid of the radical, just like in our last unit when you eliminate the fraction. It's just the first step. Now, I need to remember my property. 0 product property. I need to get 0, so I'm going to minus 3x minus 10. Minus 3x minus 10. This is going to leave me with x squared plus 1x minus 6 equals 0, making my 0 product property step 1 complete. Now, I need to factor this. I need to factor out x squared, the first term, the last term, and this green needs to be equal to 1x. Well, I know x times x is x squared, and if I pick positive 3 and negative 2, when I multiply it out and add them, 3x and minus 2x do make 1x. So I can factor this to be the following. X plus 3 times x minus 2 equals 0. I have wrote it out as a product, and the property is saying when does it equal 0? Well, x can be negative 3 and x can be 2. These are my solutions. I need to check both of them. My first one, what I'm going to check, case 1, I'm going to check negative 3. So I'm going to plug in negative 3 plus 2 equals the square root of 3 times negative 3 plus 10. On the left, it's going to be negative 1, which is equal to negative 9 plus 10. And negative 1 is equal to the square root of 1? Yes. The square root of 1 can be positive or negative 1. Case 2. I'm going to plug in 2. 2 plus 2 equals square root of 3 times 2 plus 10. 2 plus 2 is 4. 4 is equal to 6 plus 10. 4 is equal to the square root of 16. And that indeed equals 4. So both of these solutions do work. X can be negative 3 or it can be 2. Number 10. Again, similar premise. I need to get rid of the radical. So in order to get rid of the radical, what I'm going to need to do is I'm going to look at the index. There's no index. Well, it's to the square root. So I'm going to raise each power to the second. This is going to result in 2x minus 11 equals x minus 7 times x minus 7. I have to remember the 0 product property. Well, is it equal to 0? Not yet. So let me multiply x minus 7 times x minus 7. X squared minus 7x minus 7x plus 49. So this is going to be an equivalent equation where x squared minus 14x plus 49. This time I see I'm going to go ahead and get rid of my 2x. I'm going to get rid of my 11. and then this is going to result in 0 equals x squared minus 16x plus 60. It is equal to 0. Now I have to write it as a property. So I'm going to go ahead and now factor my first term, my last term, x squared, 60. What factors produce negative 16? Well, looking at x, it has to be x times x. And looking at 60, well, I know 30 times 2 is 60, but that's not going to produce what I want. So I'm going to go ahead and look at the factors of 60 to see if anything works its way up. 1 and 60, 2 and 30, 3 and 20, 4 and 15. How many 5s go into it? 12. And then how many 6s go into it? 10. And I see it. You notice how 6 and 10? 6 and 10 make 16. 6 and 10 make this green number. And I can make the green number because it's a positive 60. So this is going to be a negative 6 and a negative 10, resulting in negative 10x, a negative 6x, making my negative 16x and my 60. So I can go ahead and factor this to be x minus 10 times x minus 6, and I have factored it as my product. My property is just to look at it and say, this makes 0, and this makes 0. Let's check our work. Case 1, when x is equal to 10, that means the following. The square root of 2 times 10 minus 11 is equal to 10 minus 7. The square root of 20 minus 11 equals 10 minus 7 is 3. The square root of 9, is that indeed equal to 3? Yes. Case 2, when x equals 6. I again substituted in 2 times 6 minus 11 equals 6 minus 7. This is going to turn to be 12 minus 11, which is negative 1. The square root of 1 is indeed equal to negative 1. These are both solutions. So my answer is x can be 10, x can be 6. So when you're looking at it, number 9 and 10 set the precedent on how to do 11 and 12. The idea is in these, they're a little more complicated. The idea is that you need to get the radical by itself. So for 11, what I need to do is get this radical by itself. I am going to go ahead and I'm going to add 5 to both sides. So I add 5, and I'm going to write out my equivalent equation where it's going to be x minus 2 is going to be equal to the square root of 6x minus 5. This has an index of 2. So I'm going to take my same guy and raise both sides to the index. The index is 2, 2. This is going to make x minus 2 times x minus 2, which is going to be 6x minus 5. Radical gone. Now I can go ahead and solve using my zero product property. My goal is to get it to equal to 0. So I'm going to multiply out x minus 2 times x minus 2. X times x, x squared minus 2x minus 2x and positive 4. This is equivalent to x squared minus 4x plus 4 equals 6x minus 5. I'm going to keep my x squared. I'm going to make the right side 0. So I'm going to go ahead and subtract 6x. I'm going to add 5. This is going to create an equivalent equation where x squared minus 10x plus 9 is equal to 0. Product. Time to factor. X squared, 9. I need to figure out what can make negative 10. I know x times x is x squared. I know that negative 9 times negative 1 will create positive 9. And I also know negative 9x and negative 1x combine to be negative 10x. That being said, I've completed step 2, the product. So it's going to be x minus 1 times x minus 9 equals 0. Step 3, well, when does this equal to 0? 1 and 9, my property. All I have to do now is check. So with my first check, what I'm going to do is I'm going to plug in 1. 1 minus 7 equals negative 5 plus the square root of 6 times 1 minus 5. So I'm going to solve. 1 minus 7 is negative 6 equals negative 5 plus the square root of 6 minus 5. Negative 6 is going to be equal to negative 5 plus the square root of 1, right? Now, if I wanted to, I can also get that I could add 5 to both sides, but we can see that this is going to work out. The square root of 1 could be 1 or negative 1, meaning that case 1 works. Case 2, time to substitute. X is 9. 9 minus 7 equals negative 5 plus the square root of 6 times 9 minus 5. 9 minus 7 is 2 equals negative 5 plus 6 times 9 is 54 minus 5. 2 is going to be equal to negative 5 plus square root of 49. 2 is going to be equal to negative 5 plus 7. 2 is going to be equal to 2. Boom. Both of these are solutions. Number 12. Same idea. Before I get rid of the radical, get it by itself. I'm going to, well, I see negative 4 is cramping its style. So I'm going to have to add 4 to both sides. All right. Adding 4 to both sides reveals I have 9 equals square root of 2n plus 81. So what I'm going to have to do is I'm going to have to square both sides. This is going to result in Square root of 2n plus 81 equals 9 squared. This is going to turn into on the left. It's just going to become 2n plus 81. 9 squared is going to be 81. Now it's a matter of solving. And it's going to end up being 2n equals 0. One number times 2 is 0. Well, n is 0. Let me check to make sure that this is good. So I'm going to go ahead and plug it in. Negative 4 plus the square root of 2 times 0 plus 81 equals 5. Negative 4 plus 81 equals 5. Negative 4 plus 9 is indeed equal to 5. So 11 and 12 have been just simple examples of essentially how sometimes you might end up with a quadratic that you need to solve. Other times it might just be one solution. The idea is you should be able to solve radical equations by getting rid of the radical using inverse operations. Hope this helped.